Section 3.1 Tangents. We're going to do a problem on tangents. The problem states that fx equal to x squared, and AB is a point that's below the graph of f. In other words, b has to be less than a squared. Now we're supposed to find the two lines through AB that are tangent to f. Now in calculus, lines always mean straight lines. We don't care about any other kind. So we have, here's the here's the parabola, okay, the x squared, y equal to x squared, and then we have some point that's under the parabola. Let's say this is AB, and we need to draw that tangent line that goes through the parabola. Well, something like this. It touches at a certain point, and we will call it w squared. And we're trying to figure out the equation of the two tangent lines. In doing that, we need to figure out what w and w squared is. So to calculate the tangent line, we have first we go by the definition of the tangent, which is f of x minus f of at this point of the tangent. So by the definition of the tangent line, we have limit as x approaches w, okay, of x squared minus w squared divided by x minus w. That because we're calculating tangent at that point, and that when you calculate the limit, that will be equal to x plus w. That's a difference of squares, so it always factors out this way. X minus w divided by x minus w, which is equal to simply so we have just x plus w left, okay? And then as x approaches w, we get 2w, and that is the limit. Now if we have, what does this mean? The limit of this tangent line is actually talking about the slope of the tangent line. So remember that this is talking about the slope, OPE. So the slope of our tangent line is that. And the next thing we're going to do is calculate the relationship of this. So the slope can also be calculated as w squared minus b, okay? This is the slope calculation minus w minus a. This is also the slope of just this line going through AB. And that has to be equal to the slope we just calculated. And the reason we do this so that we have two different situations, and we're trying to find out the equation for w, which seems, and that should give us what w is, because we have a and b is the constant here that's given to us, and w is what we're looking for. So with this relationship established, let's crank it out what w is. So w squared minus b, multiply this stuff over here, we have 2w minus 2aw. 2w squared. And then we have that, therefore move everything to this side. We have w squared minus that one, and then minus 2aw plus b. And that will be equal to 0. That is a quadratic equation. Remember, a and b are just constants. So we have w is the only thing we care about. Applying the quadratic formula from algebra, we get w equal to this coefficient minus of this coefficient, which is plus 2a, okay, and plus it minus square root of this coefficient squared, that's 4a squared, minus 4 times that times that, so it's minus 4b, and all divided by 2 times the coefficient of this, which is just 2. And then we simplify this a little bit. We can factor out the 4 out of the square root, and it becomes 2. So there's a 2 here, 2 here, 2 here, so they cancel out. And what we have left is a plus or minus square root of a squared minus b. And this thing, remember, b is less than a squared. That's important because then the square root makes sense. You're not subtracting too much. And that is the value of w. So the point, we have now found out where the point is. W and w squared, whether it's here or there, is the 2 points, okay, where you have plus and minus. and that gives us the point, but we are supposed to find the equation of the line. Now to find the equation of the line, then we do the 2-point formula, which says that y minus b divided by x minus a is equal to 2w, which is the slope. Actually, we're just going to do the slope formula, which might be faster. So 2 times the w, which is a plus or minus square root a squared minus b. And that is the two equations of what we are looking for. You see, each one is one equation. And then you can write that out longer, but this should be sufficient. This is as short, as simplified as it's going to get. The next problem we are going to talk about, I'm just going to talk about it briefly because it's listed as a difficult problem in the book, but actually there's a very simple way of doing it. The problem states that if you have a ceiling like this, here's your ceiling, and from the ceiling you hang a circle. Here's your circle that you're hanging, and the rope you're hanging with is 4 foot long, and your circle, okay, this is a circle, a perfect circle. The circle has a radius of 1. So this is 1, that's 4. All right, and then what your problem is that you have a bug with legs that's crawling up the circle like this. And as it crawls up, as you can imagine, eventually there's one point where we'll first see where the rope is attached to the ceiling. The question is, where will the bug first see it? Well, that would be exactly where the tangent from the ceiling is going to touch the circle. That is something like this. Okay, that is the tangent. And the question is, where is that point, given these dimensions? Well, to calculate that, all you need to do is connect the tangent to the center of the circle. And in elementary geometry, we know that a circle, the tangent to a circle is perpendicular to the radius, where the radius connects to the tangent point. So this is a right angle triangle. This is a right angle. That means, okay, this is 1. This is also 1, because that's also the radius. This is 1, this is 1, this is 4. Which means we know what this angle is. Let's call it alpha. Okay, so alpha is equal to the inverse cosine. Okay, cosine inverse of 1 over 5. With a calculator, you can quickly calculate what alpha is. And once you figure out what alpha is, then you can figure out what this thing is, the beta. The other angle, the beta, is of course beta here is simply 90 degrees minus alpha. So once you find out beta, draw a perpendicular line here. This is x, this distance here, and this little distance y. And x and y are what we're looking for because that gives the coordinate of that point. So x is equal to cosine beta, and y equal to sine beta. And that concludes what we're looking for. X and y together gives the location of that point. And as you notice, I haven't said a thing about limits and tangents, tangent being the limit of something. That's because there's no real point working too hard. This is a very easy problem if you just use the geometry. And we'll do a lot of limits after this section because that's where derivatives are defined.